Lake Baikal, a magical place, fantastical ice, clean waters, a dramatic geography, and of course, a unique ecosystem which has developed over the past 25 to 35 million years. And of course, a place like this just beckons you to come and experience it all for yourself. To discover what this amazing ice is all about, we're going on board this hovercraft, and we'll be joined by biologist Maxim Timofeyev. He's been studying the wonders of Baikal and how it can contribute to modern science, and he'll be our guide today. Maxim, hi.
Hi.
Thanks for meeting us out here. Incredible view, I can say. Tell me first about Baikal. It's pretty old. In fact, we don't really know how old, but at least up to 35 million years old. Why is it so different from other lakes, and it shows no sign of drying out? What's the key to its longevity?
Yes. Baikal is ancient and estimated to be around 25 to 35 million years old. It's the most, or second most, ancient lake on our planet. A key feature of Baikal is that it doesn't really get older like other lakes. It's constantly growing. Any continental lake slowly fades from the moment it appears. They fill with silt in a process called sedimentation. And little by little, sediment fills the lake to the top, and it's no more. In Baikal, sediment also accumulates, but unlike other continental lakes, it constantly widens. Baikal is of tectonic origin. It's a rift lake. The rift in the Earth's crust is constantly growing, so every year Baikal is getting deeper by a centimeter. The sediment doesn't accumulate fast enough to outpace the lake's growth. Each year Baikal gets deeper and wider by a centimeter or two. It's believed Baikal will become part of the ocean in the future, tearing the continent of Eurasia apart and joining the Arctic Ocean.
If I just heard you correctly, does that mean you think that this eventually will become part of the ocean?
Yes, this is a hypothesis. Humanity probably won't be around to witness it. It will take tens or hundreds of millions of years. But geologically, Baikal is a future ocean. At some point in the future, there won't be any Lake Baikal, but a Baikal fjord instead.
So here's my question about earthquakes. We know that they happen all the time around here because of this continental rift. We know that in 1959, one of these earthquakes deepened the lake by 20 meters. We know that recently there was just another earthquake. Do we expect any more big earthquakes to happen here?
Baikal is constantly growing, so earthquakes occur here daily. Every day we have dozens of them, but we register only a few. Stronger earthquakes happen every few months. We had one just this week. It was magnitude 5, and we all felt it. And it's all right, really, if you aren't afraid of a little shaking. We don't expect any massive earthquakes, because Baikal relieves lithospheric pressure. It doesn't accumulate here. No massive energy release is going to happen. Instead, it's gradual. We've adjusted to this and live happily.
Cool. Let's take a walk and see what else we can find around this great big lake.
Okay.
So Maxime, If you take a piece of Baikal ice, it is astonishingly clear. Why is that? I mean, in some places you can see up to 40 meters through the ice.
The water is pristine in Baikal. Mineralization here is under 100 milligrams per liter, which is extremely low. It's super fresh water, close to distilled. Very few organic components are dissolved in it. It's not just clear, it's so clear that you can drink it. So when it freezes, the ice is as transparent as glass.
So obviously not here, but there are some famous bubbles and cracks that we can see under the ice. What are those cracks? What are they made of?
Gases frozen in Baikal have different origins. First of all, there's simple snow, methane, and other gas sources at the bottom of the lake. In places where the concentration is high, cavities emerge in the ice, sometimes so big you can fall into one, but they're usually safe.
The ice is very strong. It can hold people, it can hold trucks, it can hold massive vehicles, but at the same time, we see fissures and cracks all over the lake. Is this safe for us to be out here?
Sure. In some places, you must watch your step. There are places where the ice is constantly moving. Some cracks always move when the ice sheet is forming, creating cavities that are in fact good for local fauna. Seals in Baikal use them to survive under the thick layer of ice. In general, the lake is quite safe during certain periods, like in February and March, when you can walk and even drive across Baikal freely. But before and after that, you have to be very careful.
As I understand it, Baikal is home to about 3,500 endemic species unique to Baikal, which is more than any other lake in the world. Why is it so special here? Is it because of the size of the lake?
I'd say it's the age. Baikal is not simply big, it's ancient. Its basin is over 25 to 35 million years old. Over that time, the fauna has evolved greatly. At some point, ancient, warm biome animals lived here. Then ancient cold biome animals. A lot has happened over its long history, which affected the biodiversity of the lake. Then there's its sheer size. Baikal is simply so big that unique species can form in different parts of the lake. Some live closer to the surface, some live at the coastline, some in the extreme depths, 1.5 kilometers down. Baikal is 1,642 meters deep. Even at the deepest point, unique life forms exist. Species in those biomes are not alike, and the more varied habitats you have, the more diverse the fauna. That's the reason so many species exist in the lake, and we suspect the surface has barely been scratched. Conservative estimates suggest only half of all life forms in the lake have been discovered, while optimistic estimates suggest only a tenth are known to us.
So we hear about environmental crisis here in Baikal from time to time. You've said that the lake can actually clean itself. How does that work?
When we talk about the environmental crisis around Baikal, we have to understand that Baikal is a gigantic lake. Its surface area is comparable to that of many European countries. So we cannot say that the whole of Lake Baikal is in crisis, or that there is no crisis at all. Some areas have real problems, especially those affected by human activities, near towns, villages, and tourist facilities. Still, 99% of Baikal is a self-cleaning ecosystem. Anything that lands there naturally, any organic substance, wind-blown dust and debris, is quickly dissolved in the water due to the low level of mineralization. The water in Baikal is almost distilled. What remains is consumed by the local microorganisms. There is very little organic matter in Lake Baikal, so the competition between the many endemic species is fierce. Everything gets eaten up, so Baikal has a system of biological self-purification. This is why the lake's water has stayed uniquely pure for millions of years. In some areas, however, human influence has exceeded the system's ability to purify itself, leading to various crises. This mostly affects shallow arms or isolated parts of the lake. But thank God, so far Baikal has managed to mitigate all the problems humans have created.
Climate change, it's a big trigger for a lot of people. How does climate change affect life here in Baikal?
Global warming is a funny thing to talk about when you're at Lake Baikal in winter. You see, Baikal is a territory with a strongly continental climate. So the negative effects of global climate change are felt here more than anywhere else. We're seeing more climate anomalies, with hotter summers and colder winters, more winds and storms than usual. It's all because the relative balance of the climate is being upset. Baikal has its own story to tell about global climate change. We've been monitoring the lake's water temperature for more than 75 years, and we know that the average annual surface temperature has been rising. In 70 years, it has risen by more than 1 degree, which is a lot for a lake as cold as Baikal. Changes in surface water temperature have a direct impact on so-called primary production, that is, the population of microscopic algae that live in the surface layers and produce organic matter. Cold-loving algae decrease in number, while warm-loving species increase. This leads to fundamental shifts in Baikal's ecosystem. It's hard to say how this story will end. On the one hand, Lake Baikal has undergone numerous climatic changes. It used to be a tropical lake. Then it was covered in ice completely. But each of these changes brought dramatic shifts in the composition of the ecosystem and its biological characteristics. Throughout its existence, humankind has witnessed the lake in one state, the state it is in today. If this state changes, I'm afraid that neither society nor the economy around Baikal will be prepared, especially if change happens quickly. So what researchers need to do is find out what's happening and what to expect.
Something that I wanted to ask you about that you have specific expertise in is some of the species here in Baikal might be able to help scientists in medicine discover new antibiotics. Tell me more about that.
Baikal has unique deep water fauna. The deep-dwelling species of Lake Baikal are an interesting phenomenon. You see, there is not much food down there, so the bottom organisms, called scavengers, don't have any other options but to feed on decaying biomass, such as dead organisms, that are often the source of various infections. As a result, there are thousands of scavenging organisms living at the lake's bottom that produce antibiotics to combat various infections they get with food. The antibiotic substances they use are concentrated. No one has ever looked into this before. No one has ever had access to these thousands of species with their highly effective bioprotection mechanisms against infections. So we picked this area for our studies. Once we started, we immediately came upon a vast number of potential antimicrobial compounds and even described a new class of antibiotics, baikalomycins. I believe many more groups of antimicrobial compounds produced by Baikal's organisms and having potential for pharmaceutical application will be found in the decades to come. It's a long way, of course, from the discovery and first characterization to the pharmaceutical market and medical use. But still, the Baikal fauna is a valuable source of potential bioactive compounds with an antimicrobial effect.
Okay, so I have to ask, almost as a novelty, but it's really cool, Baikal Ice Caves. They're not found anywhere else, so why do we find ice caves on this lake?
The waters of Baikal are very mobile. There's always something happening, either due to strong humid winds or to the movement of the waves running into the shoreline and destroying it. The erosion of the lakeshore, its continued destruction, results in the formation of deep caves, So in the autumn, when Baikal starts to freeze over, when ice is formed, it's usually the season of storms on Baikal. The caves are showered with water from storms, forming the breathtakingly beautiful ice grottos famous on Baikal. Due to their unique aesthetic value, the caves are a fascinating tourist attraction and one of Baikal's iconic landmarks. You have to see Baikal's ice caves at least once in your lifetime. It's an absolute must. They are really beautiful.
And that sound you hear is Lake Baikal actually breathing.
Baikal is enormous. It's as big as a European country like Belgium. And I bet you're wondering how deep it is exactly. Well, it's more than 1.5 kilometers deep at some points. To put this into perspective, you could measure it with 2 Burj Khalifas, 3.5 Petronas Towers, and about 12 Great Pyramids of Giza.
To discover what's under the ice of Baikal, we're going to be joined by Igor Khanayev. He is a professional diver and scientist, and he is actually down there right now. When he comes back, he'll tell us the secrets of the depths of Baikal. Igor, thank you very much for taking the time. I have to ask, it's cold, it's dangerous, it's icy by the nature of it. Why do you do it?
Well, humans are made in such a way that they get used to anything. You only feel the cold for the first 30 seconds, a minute at most. The cold burns your face, but everything else feels pretty normal. You start feeling cold if you don't move enough underwater. You really start freezing after spending 30 or 40 minutes down there. Speaking of how dangerous it is, the cold itself isn't the main danger. There are other factors there that shouldn't be overlooked.
Jacques Cousteau and his famous team, they even did their diving in Baikal in the wintertime. What can you find under the ice during the winter that you can't find in the summer?
First of all, what you find there is clear ice. It's amazingly clear. When the ice isn't covered with snow, a diver floating underneath a meter-thick layer of ice can see the face of a person standing on the ice clearly, every feature. And if that person lies face down on the ice, the diver will even be able to see the color of their eyes and the diameter of their pupils. Now, imagine coming from smooth ice to an area full of pressure ridges and cracks, with ice piling up to 10 meters thick, both on the surface and under the water. Imagine moving among all those massive structures and shapes made of ice, and they're all transparent, the ice sparkling and playing in bright sunlight.
Choosing where to dive is a big deal, and it takes a lot of preparation. What goes into picking your spot and maintaining it, and how do you decide where you're going to dive?
During our dive this time, our goal was to pick sponge larvae, which appear in great quantities at this time of year. With that in mind, we picked an area at a depth of 10 to 17 meters and moved towards the shore, starting at the lower depth. So it's all determined by the goal of the dive. For example, we can dive in an open lake when studying underwater incrustation. Now it's cold, so the layer of ice keeps growing thicker by several centimeters each day. But once that process slows down, the bottom side of the ice immediately gets covered by a colossal amount of various diatoms. It's like walking among vegetable patches in a garden, only in this case they're above you, on the bottom surface of the ice.
What kind of equipment does it take to keep you safe and to keep you dry down there and warm?
Here's the kind of gear we can use for diving in Baikal. It's very seldom that we wear wetsuits here, so a dry diving suit is a must. Another must is a double regulator valve. We're going to need 2 of those. and that's all because of the cold water. In a wetsuit, you won't last more than 15 to 20 minutes at this time of year. I'm going to use a dry suit with as much layering as possible underneath to keep my body warm for a longer time. So why two regulator valves? In cold water like this, a valve can start free-flowing at any moment. That is, bleeding air out. Another thing, it can just cut off my air all of a sudden. So I have to be alert and always ready to close the faulty valve and switch to the other one. So we always use double-valve scuba cylinders in Baikal.
Are you ever scared? Do you ever get frightened from being down there? I mean, if something goes wrong, you're trapped under some pretty thick ice.
The thickness of the ice doesn't really matter here. Whether the ice is this thick or this thick, you can't abort your dive and go up to the surface at any moment anyway. The biggest challenge here is the closed space, of course, which scares many people the moment they lose sight of the hole in the ice. The moment they can't see it, they start to panic. As you see here, we dive with a safety rope attached. Goal number one for the diver is not to get entangled in the rope. For the person manning the safety rope, the task is to keep it taut so that he can feel the person on the other end of the rope. There has to be a constant connection. Another factor is the lack of light. Whatever the situation, you must be able to find your bearings underwater. You must know where the hole in the ice is, even if you can't see it. That's it.
Do you have a dream to going to the deepest spot of Baikal? I mean, if you could, I mean, as a diver, it's difficult, but what would you find if you went to the absolute deepest spot of the lake?
You think I've never been there? My deepest dive to the bottom of Baikal in a manned Mir submersible was at 1,580 meters. What's there to see? Deep water diving missions are incredibly interesting, especially for a biologist like me. I'm a biologist, an ichthyologist, and my main object of study is the cotidia and sculpins in particular. And it's fascinating to observe absolutely everything, such as how various organisms adapt to complete darkness and extreme pressure. And yet, there are cases when benthic fish, those which rest on the seafloor, can adapt in open water. Studying the hydrological profile is also fascinating. Gas emissions, for example, and the overall landscape that may seem to be as barren as the surface of the moon, and yet is thriving with life, if you look closely at it. And that's under extreme pressure that requires extreme adaptation capabilities from living organisms.
I have to ask you about the famous black circles that appear on Baikal. Some people think that they are UFOs or from extraterrestrial origins. So what are these circles in reality, and how do they form?
That's a most fascinating phenomenon here on Lake Baikal. That's not just hearsay. It can be observed from orbit, and satellite images have been taken of those enormous, fascinating rings. The explanation is actually quite simple on one hand, yet on the other, there's this unique ecosystem within Lake Baikal. Do you know what methane is?
Gas. Yeah.
Gas hydrates are released through fractures in the lake bed. Methane hydrate, a solid compound, is lighter than water and goes up to the surface. Then solid methane turns into gas. So if you have a piece of methane sediment this small, it will cause intense churning of water once it reaches the surface. Going up, the gas captures large quantities of water from the bottom along the way. Now, let's think logically. The gas carries a lot of deep water. Water temperature under the ice is close to 0, or maybe 1 degree Celsius at most. The temperature at greater depths is constant at around 3.1 to 3.4 degrees Celsius. So when the warmer water goes up, it's evenly distributed in circles and melts the ice.
We hear a lot about environmental concerns about Baikal and that a lot of pollution keeps coming into the lake. When you're down under the ice, are you seeing the effects of this pollution?
Researchers have registered high concentrations of phosphates, phosphorus, and nitrogen in the areas of human economic activity. In these places, the underwater picture of change is really nasty. Realizing that all this is happening right in front of you and you can't do anything to stop it can be really hard. I'm not a utopian, I'm an optimist. I'm sure that in the long run we'll come to the realization at all levels that it can't go on like this, and changes will follow. But once again, don't think that Lake Baikal's entire ecosystem is affected. That's not true. I'll give you a figure: 23,000 cubic kilometers. Lake Baikal's vast quantities of water are capable of undoing the effects of incoming pollutants.
Your colleague told us that Baikal fundamentally cleans itself as an ecosystem.
It doesn't matter if the ecosystem can manage the negative effects on its own or not. If there's damage, the balance is upset. We must help Lake Baikal cope. And let's not forget that the most endemic species inhabit a narrow stretch along the shore. If we see that the endemic forms of life are ousted, we must help and do everything we can to reverse the process. As humans, as a civilization, it's our duty.
Thank you very much. Igor, it's been very interesting to hear your thoughts. I want you to stay safe and stay warm, okay?
You're welcome to Baikal.